Now on the output transformer side, output voltage will be obviously proportional to the output current. So I will say that VO is proportional to IO, or I can also replace the proportionality sign with some constant. So VO is equal to K times IO. Therefore, my final expression VO becomes this K, which will be some constant, multiplied by IO. I've got IO as 2A1 V2 plus 4A2 V1 V2. Let us now replace for V1 and V2. So if you remember V1 and V2, V2 is my modulating signal and V1 is my carrier signal. We have assumed expressions for V1 and V2 as V1 is Vc cos 2 pi fct and V2 is Vm cos 2 pi fmt. So let's replace for V1, V2 using this sinusoidal terms. I will collect all the constants in the first term, call it capital A. V2 was cos 2 pi fmt plus I will collect all the constants like 4A2 into K, everything inside a new constant B. I'll just keep 2 outside, extra 2 available with me. You will see the reason immediately. V1 is carrier Vc cos 2 pi fct. Vc is taken inside constant B, so I'll just write cos 2 pi fct into V2 is Vm cos 2 pi fmt. Vm is again clubbed inside the constant B, so we will just write cos 2 pi fmt here. And you will now immediately see why we had kept that extra 2 available and not included it inside B. It's because I'll keep B as it is. I will now apply the formula of 2 cos A cos B, and the formula of 2 cos A cos B turns out to be cos A plus B. So that will give me cos 2 pi fc plus fm plus cos 2 pi fc minus fm. And this is what precisely we were looking for. If you remember, these two terms represent upper sideband and lower sideband. We did not want carrier in my output signal, and that is what we have achieved. There is no carrier frequency. Please note that this first term that we have is not carrier frequency. It is the original modulating frequency FM, which is also unwanted signal, but it is not the full carrier signal that comes out in case of DSB-SC. So we have to major extent achieved the purpose that we want, only the 2 sidebands at the output side. There is one extra component present which is modulating signal, but it will not take up so much power that was taken by carrier signal. So I will improve my power efficiency greatly. Now the question is, how can I remove the modulating signal? If you observe carefully, the frequency spectrum will look something like this. You will have FC plus FM and FC minus FM present at some very high frequency, and FM is a frequency that will be present on the lower frequency side, and somewhere in between the two we will have the carrier frequency present. But please remember that carrier signal is not present physically. We are just marking FC here, but it is not there in the output. On the right hand side we have FC plus FM, and on the left hand side we have FC minus FM. This frequency on the lower side is FM. So how to remove FM and get only the other 2 frequencies? It's very simple. You can see there's a large gap between FM and the 2 sidebands. So all you have to do is use a bandpass filter and extract the 2 sidebands and not allow FM to come in the output side. The output bandpass filter has to be centered around FC and should have the bandwidth of 2 FM, and this is what we exactly had in the circuit that we had discussed. So if you look at this circuit, there was a bandpass filter at the output side, and we had written that its bandwidth is twice FM, and it will extract the 2 sidebands and block any other frequency that we have in the output signal. So with this we conclude that my output consists of only the 2 sidebands and the carrier is suppressed, and hence the whole circuit acts as a double sideband suppressed carrier generator.